Hello learners, this is Education Online program. With you is teacher Rose Hezekiah, and I'm here to present for you a lesson in chemistry for senior 1. Our topic for today is continuation on acids and bases. As in my previous lesson, I have elaborated so many applications of acids and bases. Therefore, as acids and bases are of benefits to our daily life, and they have got various applications in our lives, they have also got effect in our environment. So in this lesson, we are going to look at the effects of acids and bases in the nature. So one of the effects of acids in nature is what is known, or is the phenomena of acid rain. So we have effects of acids and bases. Effects of acids and bases. So acids and bases also have got acids and bases have undesirable effects on the environment. They have got undesirable effects on the environment. And as I mentioned, I said the first one is the phenomena of acid rain. The first is acid rain. So acid rain is a result of industrial activities. So when industrial processes release gases, acidic gases, into the atmosphere, so when industries operate, they release acidic gases such as sulfur dioxide, nitrogen dioxide, and these gases moves in the atmosphere. So when these gases accumulate in the atmosphere, they combine with the rainwater, and then they form what is called acid rain. And this acid rain has got a negative impact, have got a number of environmental problems. Again, I said operation of industries releases gases such as sulfur dioxide and nitrogen dioxide. So these gases, when they accumulate in the atmosphere, and when rain comes, they will be washed by rain. And once they are washed by rain, they combine with the rainwater, and then they form what is called acid rain. And acid rain has got negative environmental impact. One is that acid rain destroys buildings and structures made of limestone. So acid rain destroys buildings. Acid rain destroys buildings, and then structures made of limestone. It also destroys structures that is made of limestone. So this is one of the impacts. I said as a result of environmental or industrial activity, we have what is called acid rain, and this acid rain destroys buildings and then structures that are made of limestone. So Also, this rain or acid rain is running on the surface of the earth, then this rainwater that contains acid is added to lakes. This rainwater that contains acid is added to lakes and then rivers. Therefore, they also have negative impact on the aquatic environment. That is, when this acid rainwater is washed and then it runs to lakes and then rivers, they kill aquatic animals. They kill aquatic animals. They kill aquatic animals as well as aquatic plants. Then acid rains also causes nutrients to be leached out of the soil. So this acid rain also remove nutrients from the soil. So removing nutrients from soil, which means it will reduce the fertility of the soil. Therefore, it removes nutrients from soil. Then trees also, it reduces the fertility of the soil. Therefore, the plants, the green environment, that is the ecosystem, the plants that are there will be deprived from the what? From the nutrients that they are supposed to get. So, because of acid rain also, we have ions are freed from clays as aluminum sulfate. Because of acid rain, we have aluminum ions, that is Al. Aluminum ions are freed from clays. That is, these ions are there in clays, so the acid rain will wash them out from those clays. Then as aluminum sulfate, then they will, instead of existing as aluminum sulfate, they will be broken off into aluminum ions and sulfate ions. Therefore, as aluminum ions are free in the clay, these aluminum ions have got negative impact. They damage the roots of plants, specifically trees. So the trees will be unable to draw enough water through the damaged root. Then this may lead to the death of the plant. Then B, we have problem of tooth decay, which is almost now widespread. This tooth decay is because of the presence of bacteria that is in our mouth. The bacteria change food that is thick in our teeth into acid. Bacteria inside the mouth change the remaining food that is thick into our teeth. The bacteria changes this food into acids. Then these acids, the acids produced will dissolve the enamel. That is the outer layer of the teeth. So once it dissolves the enamel, then immediately the teeth will what? Will decay. That is making a hole. The teeth will decay, and once a teeth is started decay, then it will do what? It will give us pain. We feel pain. We have bacteria in our mouth, will change remaining food. The remaining food that is stuck in our teeth will be changed into acids. And these acids will dissolve the enamel. That is the outer layer of the teeth. Then this outer layer of the teeth, when it is dissolved by the acid, then the teeth will start to decay. It will start to break down small by small, making a hole in the teeth. So once a teeth is decayed, then you feel a pain. And when it continues, it might reach an extent whereby the teeth has to be removed. So that tooth decay, it starts with a pH of, when the pH of the mouth is below 5. When the pH of the mouth is below 5, that is, the medium is more acidic. And then sometimes when we use toothpaste, the toothpaste is alkaline in solution. It is alkaline. We use it to reduce the acidic medium that is in our mouth. And once this acidic medium is reduced, then this will also reduce the what? The breaking down of the enamel. Then number C, we have stomach indigestion. Problems of stomach or problems in digestion. Problems in digestion. We have stomach, C, stomach indigestion. So, we say that in the stomach, dilute hydrochloric acid is released. And this dilute hydrochloric acid released in the stomach helps in the process of digestion. So when the stomach releases excess or more hydrochloric acid, then the reverse is true. Say that hydrochloric acid is naturally secreted in the stomach. And this hydrochloric acid helps in the process of digestion. That is breaking down of the food particles into smaller pieces so that it is absorbed by the body. So, if the stomach secrete or release, if the stomach releases excess, hydrochloric acid, then there will be indigestion. indigestion. There will be indigestion. The acid burns the lining of the stomach, hence causing. Then the acid will burn, that is lining of the stomach. It burns the lining of the stomach, and this will lead to what is called ulcers. This will lead to ulcers. So usually we are advised to take antacids that contain small amount of base to neutralize the medium from highly acidic to low concentration of acid. Then it will relieve the pain. Then lastly, the effect of acids is also acids have got effect affecting the pH of the soil, the acidity or alkalinity of the soil. So we have what is known as soil pH. Soil pH. So we know that plant growth is affected by the acidity or alkalinity of the soil. That is the degree of the hydrogen ions concentration in the soil. So when the hydrogen ions concentration is very high, we say that the soil is acidic, or the acid concentration is very high. Then it is also, then we say that when the concentration of the ions is very high, the soil is said to be acidic, and then it is very low, then the soil is termed as basic. So soil acidity is also affected by excess use of fertilizers and acid rain. Therefore, acidic soil is not good for growth of certain crops. So if the soil is too acidic, then the soil is treated by addition of lime. We say that acidic soil is not good for certain crops. Therefore, when hydrogen ions concentration is very high in a particular soil, then we add what is called lime. Lime is a mixture of calcium oxide and calcium hydroxide. Calcium oxide plus calcium hydroxide. So these two is added into the soil to reduce the high acidic nature of the soil, or the high acidity of the soil. That is, lime neutralizes as the excess acidity. Call it excess acidity. So it neutralizes excess acidity, and then so that the soil becomes suitable for purpose of cultivation. So as I have mentioned, I said acids are important. Acids and bases, they play important role in our lives. We use them, we apply them in our daily life in different activities. Also, they have got negative impact in our life. As I said, they cause acid rain because of the gases released as a result of industrial activities. Then we also see that they cause tooth decay. Then number 3, we have stomach indigestion. As well as soil pH. That is the degree of acidity and alkalinity of the soil. So these are the effects of acids and bases to the environment. We have acid rain, tooth decay, stomach indigestion, and then we have soil pH. We have soil pH. Then how do we test? How do we test, or how do we know that a solution is acidic or basic? How do we test, or how do we know that a solution is acidic or basic? So we have what is called indicators. Indicators help us detect whether a solution is basic or acidic. We have what is called indicators. Indicators are classified into 2. We have natural indicators, and then we have commercial indicators. So indicators are substances. They are substances used for detecting acids or bases. Then we have indicators are of 2 types. We have natural indicators, and then we have commercial indicators. We have commercial indicators. So we have one of the most common commercial indicator that is widely used is known as litmus. So litmus is a blue vegetable compound that is extracted from this one is a natural indicator. So we have litmus. Litmus is extracted from lichens. That is, it is extracted from a plant. It is extracted from a plant that contains a vegetable compound. So litmus shows a blue color in acids. Litmus, it shows a blue color in acids, and then red color in bases. So if we add litmus to an acid solution, it gives a blue color, and when we add it to a basic solution, it gives a red color. We get these natural indicators from plant materials that contain dyes. From plant materials that contain dyes. So plant materials that contain dyes, we can use them, and then we can extract the dye to be used as indicator. For example, we have leaves. Plants that have got dyes is like leaves of red cabbages, leaves of red cabbages that contains colored petals, that have got colored petals. Leaves of red cabbages have colored petals. Leaves of red cabbages have got colored petals, or the flowers are colored flower petals, or sometimes the one of hibiscus, or we call it bougainvillea. So these are plants that have got dyes. They show one color in acidic medium and another color in a basic medium. Also, we have parts of plants such as beetroots. Also can be used as indicator. But one of the problems of natural indicator is that the color that is produced by the plant cannot stay for a long period of time. That is, over a long period of time, the colors may change. So what is suitable for use in laboratories is what we call the commercial indicators. And these commercial indicators have got consistent colors. They have got consistent, the colors doesn't change over time. So examples of these commercial indicators are, for example, like methyl orange. We have phenol phthalate. We have litmus paper. Then we have screen methyl orange. So as I said, one of the advantages of commercial indicators is that they are consistent, their colors doesn't change over time. And we use these indicators to detect whether a solution is acidic or basic. So in our next lesson, we will look at an experiment that will be conducted using these commercial indicators to indicate their colors in acidic and basic medium. So, dear learners, we have come to the end of our lesson. See you in the next